Welcome to this RVIA training video. I'm Mick Sass, and I'm one of the 6 inspectors for the Recreation Vehicle Industry Association. Today, the topic is the sizing of electrical boxes in RVs. There are a wide variety of boxes used for several purposes in RVs, just as they are in your home. There are outlet boxes, there are switch boxes, there are simple junction boxes, or what we call J boxes. Electrical boxes are both made of plastic and metal, and they are made in a variety of different shapes and sizes, more than I could possibly show here. Here is another example of an offset box. These are used in narrow wall spaces to provide additional space for the needed wires and devices. The bottom line is that we need to have enough volume or space inside the box to accommodate all the necessary wires and devices that they may need to house. Here we see 2 offset boxes that show different methods of mounting the box to the RV's structure. The photo on the left uses wings to attach it to the plywood wall surface. The photo on the right utilizes normal screws to attach it to the walls. In both cases, and with all boxes, assure that the boxes are not altered in any way and that they are installed according to their installation instructions. For example, assure that boxes that use screws to attach them to the wall have the proper backer plate installed as seen here in the photo on the left. There are other installation requirements that may be specific to any number of different electrical boxes, and those requirements, as well as the generic NEC requirements, all must be considered. But for this video, we will look into how electrical boxes are to be sized. That is, how to determine how large an electrical box must be for the wire and devices to properly fit inside. So, let's look at how box sizes are determined so that we can install them without exceeding the maximum volume of the box. We also recommend the use of the RVIA document, A Guide to the NFPA 1192. This details many sections of the NEC, including how to determine box size. This is commonly referred to as the handbook and is a large 3-ring binder detailing information from the NEC, the 12-volt standard, and the NFPA 1192. Contact RVIA online or by phone if you don't already have a copy of these documents. The size of electrical boxes is specified in cubic inches. Here we see 3 spools of the most common Romex used in the RV industry. Although there are many 50 amp services being produced today, the 30 amp service in RVs is still the most common. For that reason, the 10 gauge sheath cable, or what's generically known as Romex, will be the largest, heaviest wire that we discuss today. It is housed in an orange sheathing. 12 gauge is now housed in a yellow sheathing. 14 gauge is either in the standard white sheathing or now by some manufacturers in multiple colors, and that is used to identify it as a 14 gauge Romex. The heavier gauge found in 50 amp services will normally be black or white and are much heavier and quite easy to identify. So this is where box sizing starts. The NEC assigns each wire gauge with a specific cubic inch size. The smallest or lightest wire in these examples is the 14 gauge, and it's seen in white. The NEC has assigned a 2 cubic inch dimension for 14 gauge wires. So for each 14 gauge wire that enters the box, 2 cubic inches of that box is used up and must be subtracted from the box's maximum volume. That means that if the box is rated with a volume of 13 cubic inches, that this single wire just reduced the remaining volume to only 11 cubic inches. The next heavier gauge wire, the 12 gauge Romex, is assigned a volume of 2 1/4 cubic inches. As with any wire entering the box, it also reduces the remaining space in the box by that amount, in this case 2 1/4 cubic inches. So obviously, the 10 gauge Romex being the heaviest wire in these examples, it is going to consume an even larger volume and is rated at 2.50 or 2.5 cubic inches by the NEC. Just remember these three numbers as we move forward. They will be important in the next part of the box size calculations. As we all know, boxes are often used with outlets and switches. Some metal boxes are going to come equipped with internal cable clamps. All of these devices also have been assigned a volume rating by the NEC. This allows them to be calculated in the box's total volume. Devices such as outlets and switches will always be rated as 2 wires of the largest gauge found in the box. For example, if 14 gauge wire is the only size found in the box, then the switch or the outlet would be counted as 2 14 gauge wires or a total of 4 cubic inches. Another example, if a 14 gauge wire and a 12 gauge wire are housed in the same box, any device installed in that box would be counted as 2 wires of the largest gauge. In this case, that would count as 2 number 12 wires and would have a total volume of 4.5 cubic inches. 2 times 2.25 equals 4.5 cubic inches. When metal boxes are used that have internal cable clamps, remember that only one clamp will be counted at the size of the largest wire housed in that box. Also, cable clamps, unlike switches and outlets, which are counted as 2 wires, a cable clamp will only be counted as 1 wire. In all cases, if 2 different gauge size wires are housed in the same box, the heaviest wire gauge is used for that device being installed. This is true even if the smaller gauge wire is connected to that device. Again, even if there are 2 cable clamps as seen in the box here, one at the top and one at the bottom, only one will be counted, and that will be counted as 1 wire. When it comes to determining how many wires or devices are allowed in any specific box, always check to see if the maximum volume of that box is marked inside the box itself. Here is an example of a plastic box on the left, which is rated and marked at 14 cubic inches in volume. You'll find that most plastic boxes are labeled with their listed volume. The metal box on the right is marked with a volume of 16.5 cubic inches, but not all metal boxes are labeled with their volume. But remember, you can also check to see if the packaging of the unmarked metal boxes has the volume labeled there. If the metal box is not marked with its maximum volume, as seen in this 4x4 junction box, then charts supplying that information must be utilized. If the chart is needed, it can be found in the NEC or in the NFPA handbook from RVIA. They are straightforward and easy to understand. The first thing that you need to remember is that most plastic boxes are marked with a rated volume. If you are using an unmarked metal box, then you will need to refer to this chart 314.16a in the NEC. So let's take a closer look at this section of the chart for an example. First, measure the box, then find the size in the inch column that matches. For example, let's use the box measuring 3 by 2 by 2.25 inches. Now simply follow across to find the volume of the box, in this case 10.5 cubic inches. Then refer to table 314.16b and use the proper volume for the wire being installed. Remember that if plastic boxes are being calculated, this may be the only chart needed until you memorize the volumes of the most commonly used wire sizes. Here, I highlight the examples mentioned earlier. You can note, if you haven't already, that the larger the wire gauge number, the smaller the diameter of that wire. So, the 14 gauge being the largest number is also the smallest wire diameter or size. Then the 12 gauge and the larger 10 gauge are both thicker, heavier wires. The wire diameter increases as the gauge number decreases. So, first simply find the size of the wire in the left column. Then, simply move to the right and find the wire volumes as discussed earlier. So here are the rules to remember when doing your box size calculations. The first is that no matter how many wires are entering the box, only one of the grounds is calculated into the volume. Devices such as switches and outlets are always counted as 2 wires of the largest or heaviest wire enclosed in the box. If multiple wires of different sizes are found in the box, the device is calculated at the size of the largest wire. So as an example, the box contains a 14 gauge Romex and a 12 gauge Romex. The device in the box will be calculated as 2 12 gauge wires, as that is the heaviest wire. Then, if you are working with a metal box that contains internal cable clamps, the clamps will be counted as 1 wire of the largest gauge found in that box. This rule also states that if there are multiple cable clamps in the box, you will count only 1 of those cable clamps. So let's do a couple of examples. First, the plastic box. Count the number of conductors that are neutral. That's the 2 whites, and they're marked as 1 and 2 here. Then count the hot leads. That's the 2 black wires, here seen as numbers 3 and 4. Now, the ground conductors, the bare wires. Remembering that we only count 1 ground no matter how many ground wires are contained in the box, here marked as number 5. Lastly, we add the outlet as a device. The device will be counted as 2 number 14 wires in size, since that is the only wire size found in this box, here marked as number 6. So now you add up the volumes of all the wires and the outlet, and you find that the box needs to be 14 cubic inches in size. Now let's do a metal box. The same procedure is followed, except that we have to remember the cable clamps. Count the number of conductors. Here, the 2 whites are neutrals, numbers 1 and 2. Count the number of hot leads, the 2 black wires, numbered 3 and 4. Now the ground wires, remembering that we only count 1 ground wire, here marked as number 5. Next, because it is a metal box with cable clamps, we need to add 1 wire for the internal clamps, even though there are actually 2 clamps in the box. Again, as with ground wires, always use the largest size wire for the clamp if different size wires are housed in the box, marked here as number 6. Finally, we will add an outlet as we did with the plastic box example. Here, we add the outlet as a device counting as 2 14 gauge wires, seen as number 7. So, this metal box must be a minimum of 16 cubic inches to accommodate all the wires and the outlet. So finally, here's an example of the information that can be found in the guide to the NFPA 1192 handbook produced by RVIA. This and much more information is available for further reference in the handbook on pages E74 through E77. Thanks for watching this RVIA Standards training video on electrical box sizing. Please view all of the other training videos available here on the RVIA Standards YouTube station.